Today we'll have our class for the fourth domain, which is the network security. And it's a super important content in this section from the network security, networking knowledge, and security knowledge perspective, network security perspective. This is a very important topic. The concepts they have mentioned in this chapter are super important chapters. These concepts are the one which are very regularly used in day-to-day jobs for the network and security administrator job. A lot of people who are in this domain, we are working in as a cyber security analyst or network analyst. The concepts in this knowledge are the most frequently used concept. This is a very important chapter from the knowledge gaining perspective, and this is what on a day-to-day basis these knowledge concepts very regularly get applied, right? So this is kind of a bit heavy chapter in terms of the content in this chapter. So make sure everyone go through this content plus the ISC2 study material, and things are not clear, we can have another class. But just to put some emphasis that this is one of the key concepts that on a day-to-day basis most of the network and security administrator do in their daily jobs. So things that they have mentioned in this chapter is a lot of things are similar to what we have studied in our previous network course and security course. OSI layer, like TCP/IP layer, TCP/IP model, IP version 4, IP version 6, common application used in these layers, some of the type of the attacks, some of the technologies used to protect from those attacks, and how different technologies work in terms of the VPNs and data centers and cloud services. So this is, in my view, in this chapter, they put a lot of stuff. It requires some time to at least understand the concept, but nevertheless, important thing is to at least try to familiarize yourself with the concepts, and at least on high level just get a grip of that, like at least of the concept. I won't understand, I won't expect you will have detailed knowledge about everything, because this is still an entry level course. So but at the same time, you should have to have the basic understanding about the concept, right? If someone's telling you firewall, you should understand what a firewall is. If someone is telling you TCP/IP model, you should understand what the TCP/IP model is, right? If someone is telling you a cloud service on a high level, I know that the cloud itself is a big domain to work on, but on a high level, you should have the understanding about the basic concept, what type of attacks comes, and how we protect the attacks and so on. To start with, this is what we have studied in our class, where we have studied the 7-layer OSI model and the 4-layer TCP/IP model, and we understand that OSI was the base that the engineering forces started to realizing how to communicate, how the networking devices or devices wants to communicate with each other, how they should communicate. They defined this 7-layer model, starting from physical link, data link, network, transport, session, presentation, application. Top four are called like the upper layer, bottom three are called the lower layer of these models. And TCP/IP evolved later on, but OSI was mainly in the initial days of this telecommunication, when a lot of vendors were doing their own protocol developments and a lot of things were evolving. So that time there was a need to define a standard. So whoever is making a protocol or developing a protocol and wants to communicate from one protocol to another protocol, and they need to somehow find a mechanism that how uh, two devices can communicate, right? So based on that, the 7-layer method technology evolves, which is called OSI, Open System Interconnect. But what happened over the period of time, internet evolved, and most of the people started using internet, and internet kind of become the standard protocol to work on. And everyone, on the internet we use TCP/IP. So TCP/IP become the de facto standard. So everyone, almost all the vendors, all the technologies that we use today, they support TCP/IP protocol. So TCP/IP is kind of become the de facto, right? So instead of, in the old days we used to have bunch of different protocols, right? So those protocols becomes obsoleted, and everything kind of standardized to TCP/IP. So which is using the IP addresses, right? You having the IP addresses, using the IP stack to communicate from one device to another. Since industry evolved towards TCP/IP using as a TCP/IP protocol, and TCP/IP is a simplified version, I would say. So what happened that later on the industry came up with a TCP/IP model that whoever wants to use TCP/IP, and most of the devices are using TCP/IP. So you just use and define, make sure that you have the 7 layer, a 4 layer network, internet transport and application layer, and you just communicate on that one. So you can say that TCP/IP is a simplified version of the OSI model, right? OSI was protocol independent because it was meant for multiple vendors coming up with their own technologies and so on. But eventually, TCP/IP is a fixed protocol, which is TCP/IP protocol, right? So TCP/IP is simplified because it's following just one protocol, which is TCP/IP, and it's a 4 layer model. After that, there's a lot of detail in the chapter for the lot of devices that we do, a lot of things that we do on day-to-day basis. The first, if you look at it, types of networks, right? We studied in our course. They have mentioned so many types of the network. Although I will tell you from the industry perspective, not everything is commonly used, right? So commonly used, you have local area network, you have wireless area network, a local area network, you have wide area network, like the long distance networks, and normally virtual private networks, VPNs, if you have to obsolete your information. And the thing is that rest of the things are not very commonly used in the industry perspective, except the storage area network. This is where you have the huge storage. Let's say if Google Gmail, you have 15 GB, and Google is providing 15 GB to everyone in the world, right? So Google have terabytes, petabytes of bunch of storage. So there must be a network behind it to how the data gets stored and all that. So that's called storage area network. That is also used in the industry very well. But commonly, you must know that from your knowledge perspective, LAN, WAN, wireless LAN, and VPN. If you know, understand at least these 4 or 5 concepts, you are at least good to go, because that's what most commonly used in the industry. Second thing, from networking devices perspective, they list down all the pretty much devices that are used in the network. But as I said again, right, commonly used devices are I list down on the top order. As normally every network has switches. Normally now they have access points because of wireless connectivity, routers, firewalls, endpoints, and server. This is everyone has it, right? And definitely printers are still being used. Maybe eventually we'll get rid of printers because printing needs are getting reduced going forward. Fax machine, you have seen that, right? No one is using fax now. Very rarely fax is used. Otherwise, 10, 15 years ago, fax was a very important communication medium. People used to send fax globally from one country to another, one organization to another, and fax is considered as a legitimate, authentic document. But now no one is using fax, right? Now we are using email. We can just send it in 1 second without pretty much any charge, right? And in fact, when you send international fax, it used to incur international call charges, which was in hundreds of rupees or few dollars. So technology is evolving. So not all the technologies is being used currently, and not all of them will be used in the future. But at least few common things which I say are not going away. At least top 5 or 6, you can top 6, I would say, are not going away anyways, right? So they will be staying. Switches, access point, routers, firewalls, your servers, your endpoints. Endpoints are the end devices, your laptops, desktops, your tablets, your phones, all called endpoints because they are the termination device where you are using the applications. So these network devices, they have listed down pretty much all the devices used in last 15, 20 years in the industry. Similarly, they have mentioned all type of networks used in the industry. But as I said, now we are using only 4 or 5 terms. Here we are using only 5, 6 terms. Similarly, network attacks types, this is evolving, right? Attacks are not stopping. Hackers are getting sophisticated and smarter. They're coming with new technologies, but these are some of the very common technologies which were used in the past, and they continue to be used, right? It's not that they are not being used, although they're evolving the new technology. At the same time, some old fashioned technologies is still in place and people are using them. So we have to make sure we have a mitigation for these common type of attacks in our network, right? And normally, like these are the technologies or tech types, but normally once they get access, they try to spoof your network. They try to inject some virus in your systems. They try to hackers try to put some worms. This is what they do, right? They try to install some phishing attacks. They try to install some rootkits and all that. So these are the type of attacks, and this is the attacks can do normally, right? So they can propagate worms in your network. They can get your system access to outside their command and control systems and so on, right? And some of the technologies that we use to protect from the attacks, right? So these are the technologies they mentioned: IDS system, a network IDS system, host IDS system, security information and event management system. So these are some of the technologies used to protect from these attacks. If someone is attacking, then these systems are the one they have the capability to detect. Because at the end of the day, hackers are doing a lot of work to attack your system, right? But at the same time, there are a lot of technologies out there which you can purchase and protect your network. This is what the job of the networking and security administrators normally is, that they use these tools, they deploy these tools, and then they use these tools to protect their networks. And also some other technologies which are used, we use antivirus. Everyone knows antivirus. We install antivirus on our laptops, PCs, and the endpoint devices. We have sometimes scan our network to make sure there is no virus. We put the firewalls on our boundary of our network just to make sure that no one is trying to get bad traffic to our network. And similarly, we have intrusion prevention system, network intrusion prevention system, host intrusion prevention system. So on the left you have network, then you have network devices, yet your type of networks, type of threats, and in the bottom you have the technologies which try to provide the necessary protection. And after that, they mentioned something about the data centers, right? So data center are the, as I said earlier, like data center are the place there where we host our servers, right? So we used to put a lot of servers in data center, because in data center you have to make sure that data center have high availability, redundancy, resiliency. Just make sure that if there's no single point of failure, even you're getting power from two power providers, two hydro providers. You have HVAC, heating, ventilation, air conditioning, right? Make sure that, because servers generate a lot of heat, so you have to make sure you have a cooling mechanism. And plus like the fire suppression mechanism is there. So when you build a data center, a lot of things you have to do, right? As I said, right, building a server in a data center is not an easy thing. You have to take care of a lot of things. You need a server at the end of the day, right? Let's say you want to host a web page, you want a web server, you to run, your organization wants to run application, you want to just have a server to run that application. But in order to do that, you have to make sure power is good, air conditioning is good, you have fire alarms, you have fire suppression. It's too much work, right? So that's the reason the concept evolved towards to cloud services, where cloud says, okay, the cloud service provider say, you don't worry about all of these things, the power, air conditioning, fire suppression, will take care of all of that. What you need, end of the day, you need a server only, right? So you can run your application, you can serve your web server, whatever you want to do. You want to do whatever you, so we'll just give you those things, whatever you need. You need a server, we give you infrastructure as a service. It's called IS. If you need a software, you want to offer, let's say, email service or some CRM service or a supply chain management system, we'll give you a software as a service. You can just use that. If you want to develop something, you want to build your own code and all that, we can give you platform as a service. So cloud service provider, whatever the problems were seen on the first thing, building a data center, they took all this headache on themselves, and they say, end of the day, you just want a server, right, to run your application, we'll give you for that, and we'll charge you monthly basis or weekly basis or whatever. And mostly cloud is pay as you go model. So cloud came up with a very innovative, very interesting idea, that you give us all the headache, we'll give you what you want, you just give us money, and we take all of your troubles on our shoulder. So this concept is very popular. Most of the common cloud service provider, uh, is Amazon. Everyone heard the name of Amazon. Amazon is a retailer, right? Online e-commerce. At the same time, Amazon has a cloud services. You can buy servers from Amazon. You can have platform as service. You can have software as service. So that's Amazon service, which give you the cloud-based services. It's called AWS, Amazon Web Services. It started with web and is evolved later on. AWS word, whenever you say, is Amazon Web Services. And at the same time, Google is offering that. Google is offering similar services even more. It's called GCP, Google Cloud Platform. Similarly, Microsoft is one of the leader too, right? Microsoft come up with the same cloud services model, and Microsoft called it Azure. So Azure GCP, AWS, they are the top leader. Although other than that, there are a bunch of other service provider, because these are top and the greatest and all that. Sometimes they are expensive, and for that reason, there are a lot of mid market players. Like I know in Pakistan and India and South Asia and Asian countries, Alibaba is very famous. Similarly, Huawei is very famous, right? So they all are good. No one is less. I would say that they all providing services which are targeted towards certain segment of the market, and they are doing their job for sure. And cloud services, when we say that I don't want to have my own data center, I want to rent the server from some cloud service provider and some cloud services, then you can have, sometimes customers say that I will go completely with public cloud, means Amazon, Google, Azure, whatever, right? It's called public. And sometimes what happened that they say that no, it's super secret, I cannot put my information to Amazon and Google, it's too insecure. Lot of time people think that, lot of organization have a lot of internal security requirement. They say that putting a server means that I'm giving my information to Amazon, Google, and these cloud service providers, so I cannot have it. So what happened? They say they build their own data center. This is what they do, right? They do go through this pain. They build their own data center. They control everything. It's private. It means that it's totally in their control. But it's a lot of headache, right? For sure. Lot of time is community based model where like community comes and collaborate and all that. And a lot of time is hybrid means mix of public, private, and community, means that sometimes some server they take it from public, and let's say sensitive information they keep it in the private, so they keep mix of different models. And some of the network terminologies that we use is virtual network. We segment the network into different segments. VPN, I think some of you might be aware that sometime, like your service provider is blocking something, or your company is blocking something, you VPN to something else. So it's kind of hides your network, and it start using the network that you're connected to. Network access control is just the way you want to control who connects to your network, and who is allowed, who's not allowed. Defense in depth, we studied last time, is multiple layers of the defense. It's not that you just do one thing. It's not that just you put firewall and you forget it. No, you have to have firewall. You have to have another layer, which could be your endpoint protection. That could be your IPS, IDS. That could be anything. So defense in depth is multiple layers of the defense. Zero trust means that you don't trust anyone, means that you don't give access to anyone, and you just control the access very selectively. Whoever needs, you give the minimum access. Means that if someone needs access to application A, he will get access to application A, but not to application B, right? So it's a zero trust, means that we don't have a native trust. There is no inherent trust. In old days, people used to trust everything. Whatever, once you connect to the network, you got access to everything. Now, zero trust means that inherently there is no trust. We don't trust anyone. If you need access, you have to ask permission, and we will allow you access to that application, and that's it. You don't get access to application number 2 and 3 and 4. And then started doing this micro segmentation, DMZs. DMZ means that there are some part of the network where you have to expose it to the internet, or let's say sometimes you have a server, web server needs to be accessible from outside, so you put in a separate zone or separate area of the network which is kind of accessible from outside. It's called DMZ. This is a very common concept on the cybersecurity or network security domains, the concept of DMZ, where some part of the network you put on a separate area which is kind of exposed to outside world, because this is required, right? Because let's say you have a web server, and you are e-commerce company, so people have to come to your web server, right, to do the transactions. So you have to put in DMZ. But maybe that web server is doing transactions, web server is in the back end is doing this a lot of database data and all that you can put in your internal network, but the front server are for sure in the DMZ. After that, we have, this is what we have studied before, MAC addresses and the IP addresses. MAC addresses are the layer 2 addresses, which are kind of burned into your Ethernet card, network interface card. NIC cards. NIC cards are on your PC, laptops. Everything has a network card, right? Whether it's a wireless network, whether it's a fixed network, your Ethernet cable goes in there, or fiber cable goes in there. You have a network interface card, NIC, and NIC has a layer 2 MAC address, right? So MAC address has two segments. One is called OUI, organizational unique identifier. One is network interface controller specific. And what happens that OUI, normally this first three yellow part you see, this is normally the organization who is making it, right? Let's say if Microsoft is making it network card, then they will have a Microsoft identification, or the code assigned to Microsoft. If someone else is making, let's say HP is making, HP will have their own HP assigned code. So with at least these three things, you can identify the manufacturer of the network card. The last three segments are basically device specific, right? Every NIC has a unique. So you can imagine that every card that you have in the world right now have a unique MAC address actually. So MAC address is a layer 2 MAC address. You see, OSI model, they go on a layer 2, right? Normally, typically, they are hard burned into your devices, on your phones or your endpoints, your servers, your desktops, where whatever device you have, your even your gaming consoles that you have, Xbox and PS4, the Ethernet interface that they have all these MAC addresses hard burned into their device programming. Although there are certain ways to spoof it, but typically they are hard burned. They are not meant to be changed. And on the other hand, IP address is a layer 3 logical addressing. You can change the IP address on the device. Although every network normally someone assigns an IP address. When we are in the home, our home router or whatever the internet modem is that assign the IP address, and that IP address normally has four dotted decimal notation, right? So, an IP addresses we studied earlier, it's basically class A, B, C, D, E, and E. D and E are special purpose. A, B, C are commonly used purpose, and IP addresses is a very important way to communicate over the internet. As I said, internet is based on the IP addressing and TCP/IP model, and TCP/IP uses the IP addresses for the identification of the devices. This is again we studied OSI 7 layer, correspondingly 4 layer TCP/IP model, right? And these are, it's important thing is that on this slide is the common application and protocol used in each layer. You can see there's network interface layer of the TCP/IP. TCP/IP network interface layer is, you can see that it's using the uh, Ethernet, fast Ethernet, token FDDI. These are the physical layer, right? How the cable connects to your device and what protocol cable is running. And mostly, as I said, Ethernet is the Ethernet, fast Ethernet are the de facto standard now, right? For the most of the communication, 90% I would say happening today is happening over the Ethernet. Our home routers, modem, they all have, our devices have Ethernet. Everyone has Ethernet. The difference between Ethernet and fast Ethernet, Ethernet is old. It used to be 10 megabyte. Fast Ethernet evolved as 100 megabytes and now 1000 megabytes and on even further, right? So technology is the same, it's just the bandwidth is different, Ethernet and fast Ethernet. The next layer is the internet layer, and that's where we have the our IP addresses get assigned, right? This IP, ARP, IGMP, ICMP. ICMP we studied is the troubleshooting protocol, and ARP is basically the mapping between the IP and the MAC address. And most important protocol you should understand on this layer is the IP, right? On this layer is you can Ethernet or fast Ethernet. Transport layer have simply two protocol. It's simple enough, I would say. It has TCP or UDP, right? We studied many times but earlier that TCP is connection oriented, is just to make sure that communication is reliable. It constantly makes sure that other end is receive the packet that is sent by one device, right? It constantly do handshake and hellos and acknowledgements. So it's a good protocol, but it has a lot of overhead just to ensure the communication is bidirectional communication is always received and so on. On the other hand, UDP is connectionless. A simple protocol is someone asks for something, it just starts sending without caring whether other end received it or not. It's fast because it doesn't care. It just do its job. Both have TCP and UDP their own use cases, right? Some cases we use TCP, some places we use UDP, but essentially internet is using both. TCP is for wherever we need more reliability, and I think mostly emails are using TCP. Sometimes voice communication use UDP. On top of that, the last one is the application layer. Application are the one that we use on commonly, right? The as an end user, you can see that what we commonly use, right? We use HTTP, that's a web browsing, right? The a lot of other application we use, right? So they have given some of the name. These are not the only application. There are many other application. Let's say, but these sometimes many application inherently adopt some of these protocols. So SMTP is an email, right? That we all use email, right? Whether we are school, university, college, job, home, wherever we use email, right? So email in the end, in the background, use this protocol. They have not mentioned here, but let's say web browsing, HTTP, right, or HTTPS, which is secure browsing. So they all are the common application. So this slide is important to understand the mapping. But this is the slide. I would say that you all should remember these numbers, because in the question are there. I think there are at least few question, one or two question around to understand the application port numbers. Because what happened that when application works, FTP is the name, but in the end it translates to a number, right? What is the protocol number used? So I would say you, some of the application you know very well, as I said, SMTP, right? SMTP 25 is your send mail, or simple mail transfer protocol, that the sending of the email uses this one, right? And IMAP is the protocol which receives the email, right? So you should understand, sending email use the protocol 25, protocol number 25. IMAP uses the protocol number 143. Similarly, web browsing, very common, right? We all do web browsing every single day. So a web browsing have two flavors. One is the simple insecure web browsing, which is HTTP, which is uses the port number 80. Secure web browsing is HTTPS, which uses the 443, and this is what the 80-90% of the internet servers are working on, the HTTPS. So these protocol numbers you all should remember. If someone asks you that SFTP, secure file transfer, what is does it use, right? It uses protocol number 22. So if you see that the way they have done is that uh, uh, I think the way I see that sometimes they have mentioned that on the left side, it was the protocols used initially, and they were kind of insecure initially, and later on they evolved into a secure protocol. FTP evolved to SFTP. Now everyone wants to use security, right? Telnet was a simple protocol. Now it's the same protocol is evolved as a SSH, just to provide a secure shell. SMTP 25 port was the without any encryption, without any security. SMTP 587, it came up with the security, means that TLS means the security is similar to HTTPS. Similarly, uh, time was the old protocol, it evolved at NTP. DNS was still commonly used. Name resolution, when we say CNN.com, it translates to an IP address. So this happens over the DNS protocol, and DNS was evolved. Initially was 53, now evolved as 853, which is DNS over TLS, means a secure DNS, right? So HTTP simple, insecure, HTTPS secure. So on left side insecure, right side secure protocols. You can say that feature it was initial deployment, and that evolved eventually as a security. So make sure you all understand, and you have spent some time remembering these port numbers. And these are some of them are very commonly used, some of them are not that commonly used, but somehow in one network or another they all are used, right? So remember these application port numbers. So this was the network, I would say, uh, uh, summary of the course, but I would quickly just show you that, this chapter, as I said, chapter number 4, network security, is a super important chapter from a knowledge gain perspective. This is what you do every day in your job if you are working a network and security administrator. So you see that, right? So in this chapter they have spent a lot of details. What is networking, and how the networks are built, what type of networks models are there, OSI model, TCP/IP model, and how the IPv4 and IPv6, we discussed that, right? IPv4 is old, IPv6 is new, IPv4 is 4 dotted decimal notation, IPv6 is 128-bit, and Wi-Fi are very commonly used, right? In our home, we use Wi-Fi. In our offices, people use Wi-Fi because it provides a lot of convenience, right? A lot of ease. We just don't need to connect any cables and all that. We just connect over wireless. It's so cool. But point of that is so cool, but at the same time, it comes up with some security risks, right? So we have to make sure that Wi-Fi is deployed correctly, Wi-Fi is secure, plus Wi-Fi have coverage issues, right? If you're going away from the Wi-Fi modem, your signal got weak, distorted, you start seeing bad performance, calls start dropping, so on and so forth. So wireless needs some more planning in terms of make sure that you get good performance. Cable network, wired network normally are good, because the moment you connect the network, normally performance is guaranteed, right? So wireless are cool, convenience great, but at the same time it needs more careful planning in terms of, and that's where a lot of Wi-Fi companies, they do the site surveys. They make sure that your how many Wi-Fi access points they need to deploy, what will be the coverage for each access point, how much obstruction you have, how much noise in your area, is there any wall blocking, is there any other thing blocking. So a lot of planning goes into Wi-Fi thing, but it's end of the day, it's a great technology for sure, and it's going to last, and it's evolving. It's getting more and more speed and throughput. So Wi-Fi is a great technology which is going to be staying for many, many, many years for sure. Security of the network is, again, we put firewalls. You see in the middle is a firewall. This is a device normally do the network security. Normally this is how the network is built in, right? We have switches connecting the lot of PCs and desktops and Wi-Fi and everything. And then whenever we have to go out, traffic passes through the firewall. Firewall see that, do I have to allow this traffic or block it? Let's say an organization says you have to block YouTube during business hours, right? So this is could be organization policy, or you have to block TikTok during business hours. You have to block TikTok always, whatever. So firewalls normally have this capability. They can allow or deny traffic based on their application and so on. So that's where a lot of control comes. And our firewall send traffic out towards your internet routers or modem, and then it goes to your service provider, ISP, whoever the internet service provider is, and that's how it gets to rest of the internet. So this is the typical network connectivity scenario. And this is the port and protocol we just discussed, right? So when we use the application, users are using different applications. User goes through the network, internet, so on. Sometimes traffic goes out to internet, sometimes internally within the networks. So make sure that that's what I'm keep emphasizing, that you guys have to make sure that all of you make sure you read these chapters. Don't just rely on the DAC. You have to go through the chapter. They have put a lot of good information, a lot of good details, and you have to make sure that you read that, right? So they have given the protocol number, port number, what each protocol does, and so on. And like there's some videos also there, so make sure that you watch the video, and you can download the transcript, whatever it is. And then the second chapter, they have given type of attacks, what type of attacks, and this is what we have studied in cybersecurity courses: malware, Trojan, threats, and how they are protected in the network through IDS and IPS systems. So this all theory is super important, I would say. Spend some time. This is a super heavy chapter. It needs some time to understand and grasp everything. But end of the day, it will be useful knowledge for sure that you can apply in your day-to-day job for sure, right? So I'll take a pause here. So make sure that you go through the slide deck. At the same time, you go through the this ISC2 official study material. This is very important, right? So I'll just take a pause. If anyone has any question, just let me know.